Good morning, physics. Today is Thursday, May 12th, 14th. Ooh, days keep on fading by. So today what we're going to be doing is we're going to be working on a project where we're finding an epicenter of an earthquake. And so this is sort of a little bit of a lab. To start off with, one of the things you're going to do is you're making a claim based on your P waves and your S waves. And if basically first claim is when S waves and P waves from an earthquake are detected at 3 locations, will the location closest or farthest from the epicenter measure the greatest time lag between wave types? And when it says time lag, it's talking about how the P waves, once again, sort of come first, they move faster, and then the S waves come. And the question is, will the lag time, if there's greater time between the P waves and the S waves, will that mean that there's more time between, or that the earthquake is farther away? So to start this off, you're going to sort of answer that claim, and then what you're going to do is calculate the lag time over 100 kilometers. And the way we're going to do that is using a little bit of math. So in this, we're given two sort of key details. We're given our speed of our P waves right here, which is 6.1 kilometers per second, and the speed of our S waves, which is 4.1 kilometers. So I'm going to write that down on something you can't see right now, because we're going to do some math about all of these things. So, let me adjust. So, we have our two waves, and then what we want to do is sort of calculate how much time it takes, like over the distance of 100 kilometers, how much time difference there is between the P waves hitting and the S waves hitting. And so one of the ways we can do this is we can sort of remember our old value, our old equation, V equals d over t. So our velocity equals our distance over time, and then if we rearrange that, our time equals our distance over velocity. So in terms of the lag time, there's a couple ways we can do it. So we can calculate the time it takes for each to travel 100 kilometers and then subtract them to figure out the lag time, which is what we'll do. So we'll do t for our P waves equals, we're traveling 100 meters, and we're dividing by 6.1, and by 100 meters I mean 100 kilometers, km per second. And then for our time, and when we do that out using a calculator, which we'll do in just a moment, and then the time for our S waves would be 100 kilometers over 4.1 kilometers per second. And so when we use a calculator to calculate that out, we get a time of, there we go. We get a time of 16.39 seconds, and then for our other one, we get a time of 24.39 seconds. So seconds and seconds. And so now what we'll do is we'll do some subtraction. And so now we subtract the two. And so our lag time would be the subtraction of each. So we'll do bigger minus smaller. So 24 minus 16 is 8 seconds. So there's 8 seconds of difference over 100 kilometers. So basically what that means is after the P wave hits, It takes 8 seconds if the earthquake was 100 kilometers away, the P wave would hit, and then 8 seconds after the P wave hits, the S wave would hit. So that's what we'll put in for our thing right here. Our lag time over 100 kilometers is 8 seconds. Okay, 8 seconds. Bam. So now we have our lag time over 100 kilometers of 8 seconds. So that'll be sort of useful for us. So now what we're going to do is we have this little chart here of seismograms data. And what we're going to do is we're going to sort of write out what the lag time between each of these different places. So if we look at Austin, we have it hit. We're going to just say 0 is when the P wave hits, and we're going to take when the S wave starts as sort of the lag time. So in this case, Austin's lag time is 150. And then Bismarck, if we look at that, it is 170, because each of those boxes are 10-second intervals. And then Portland is 120. So now we have lag times for each of these. And what we're going to do is we're going to use this equation for our measured lag time times 100 kilometers divided by the lag time for 100 kilometers. And so I'll do this one for Austin. So we'll do this first for Austin to find sort of the distance of Austin, and then I'll let you guys sort of do the rest. So for Austin, so we're going to say d Austin. So our measured lag time was 150, so that's what we'll put up here. I'll actually switch colors. So we'll have 150 seconds times 100 kilometers, because that's what it wants us to do. And then we'll divide by our lag time for 100 kilometers, which was 8 seconds. So now, when we do that, we get a value. We multiply it out, we should get basically 1.5 times 10 to the 4th over 8. And when we calculate that out, we end up with about 1,875 kilometers. And so that's sort of the distance from Austin. So we'll plug it into our table, 1,875. And I'm not going to calculate out the rest for this one. But what I'd like you all to do is sort of calculate out these. And then what we're going to do is we have this map, which shows the locations of the cities. And I have some circles here, which we can adjust the scale, which I'll show you how right now. So after you double click on it, it should open. And then we have the circle. We want to just line up its center with the scale. And with this one, we want it to go to 1,875 kilometers as the radius. So what we'll do is we'll expand it. We'll readjust. And we want to make sure we do the corner where it's sort of longer. Okay, not quite 875. 1,875. So a little bigger. And so I'd say this is probably about close enough. It doesn't have to be 100% precise, and then we'll put the dot over Austin. And so now it's over Austin, and then what you're going to do is you're going to do the same thing for the other two locations. And so we'll save and close this. The map ends up getting a little bit weird, but what we can do is we can actually do some edits to it, such as... Oh, not right now. Well, it'll look a little bit weird as it gets bigger, but you should still be able to, when you edit the image, or the drawing to adjust the size of the ones around Portland and Bismarck and get a good look of where the closest place is that the earthquake happened. And so then after you do all that, you're going to answer some questions such as describe the location of the Earth's epicenter and which city it is closest to. And then why must seismographic data, and then sort of talking about, well, what would happen if we only had 2 of these, which you can sort of do by sort of making the rings, some of the rings invisible, see what happens if you don't, if you ignore one of the rings. And then finally, you're going to sort of talk about, like, why is this data important? And yourself, you're going to do a CER with an opportunity for some extra credit. So this is what's going on for today. You're also going to be working on this tomorrow, and I'm available to answer some questions, so don't panic. And I hope you all have a great day. If you struggle with this severely, what we're going to do on Monday is actually go over this in the live class. So if you are completely clueless with what's going on, I encourage you to come to the live class on Monday, and you'll get credit for this assignment. That's all. Have a good day.